we are going to talk more sort of like technical detail and like how our stuff works and what our stuff actually is. So what we are first, we are a turnkey networking solution that you basically bring it to your environment. You let it take over your network, boot the network, operate your network, and the interface to it is very simple. It's basically VPC just like in the public cloud. So people who are growing up in the public cloud, they've used AWS networking or like whatever public cloud of your choice would be. Like they're used to this concept. So like once they land on top of our stuff, like they know how to use it and it works with all of the tools that they're used to. And it's also super simple to operate. For people who are like understand networking, they can dive under the hood. You have a plethora of like simple debug commands and operational tools, so you can basically know what's going on with your network without having to like struggle with the abstractions. And a lot of projects in the past that try to do the intent-based networking, like intent is amazing. The problem is, what the hell is going on underneath? It's always a challenge. So the VPC service is a big deal. We allow to like create VPCs, and those VPCs are kind of like network containers, and you build a lot of services around them. And we just have like simple VPC service with like peering across VPCs and peering to the outside, and a lot of exciting stuff is coming later. So we're going to be like providing like a full-on networking platform. The thing is distributed as software appliance, so you don't have to compile, assemble. It just like comes with all the batteries included. If you peek under the hood, switches, basically white box or gray box Broadcom-based switching. The support for NVIDIA is coming soon. On the software part of the product, and our product consists of both the hardware part, which is white boxes, and the software part, which is a software data plane based on VPP that runs in what we call gateways, which basically servers, or DPUs, or super smart NICs. So this way, you can have a very simple network with a lot of functionality that's augmented in software. The DPUs we're working on is Pensando and Bluefield, which is the obvious choice. But like anything that has CPU and memory can run this, like, and it can run on either ARM or x86. So if you look at the software side of things, on switches, we're on Sonic and our control plane. On DPUs, we're on our data plane and the control plane, and same thing we run on the gateway appliances. The way we're treating the network, because of the Kubernetes control plane, we basically turn the entire fabric into a huge Kubernetes cluster. So like every switch, every NIC or DPU, every gateway becomes part of the cluster. And we distribute configuration, we distribute software, we push out updates, just the way you would do in a normal Kubernetes cluster, except for you don't have to manage this Kubernetes cluster. This is like completely under the hood. So if you're a networking person and you don't want to struggle with Kubernetes and like learn new things, it's completely hidden away from you. It's completely self-managed. Questions?
All right. So first question, if it's Sonic, is it the open source, I just download Sonic, or have you made additions to it so that it's got features and functions that make it Hedgehog specific, like other vendors have done?
Great question. We come pre-bundled with Sonic. We currently support Broadcom Sonic and Dell Sonic. So it's basically the same thing. And we're going to support Edge Core and Community as well. And you'll basically have a choice, like it comes all pre-packaged. If you want to use your distribution of choice, or if you want to use your Sonic, you will be able to do that. You don't have to be married to Broadcom or whatever we decide to prepackage.
You're prepackaging for simplicity.
We're prepackaging for like basically UX. Yeah.
But there's no requirement. You can use any version of Sonic, or is
you will be. Currently, we work with Broadcom Sonic because if you want to have like enterprise features and if you want things like BGP VPN working, you kind of have to use Broadcom Sonic.
Yeah.
Because Community Sonic, like depending on the platform, the support for various things is like might not be there.
Yeah, that's where I was going to. So I know Dell has Dell Sonic and Dell Enterprise Sonic, where they've added a lot of features. So there are some additional support costs around that. So that's why I was curious who
So
version of Sonic you're using.
on Dell is basically the same as the Broadcom Enterprise Sonic. So we support both. And we basically support all of the features that come with that Sonic, and we prepackage that Sonic. But if you want to get it straight from Dell, we'll still work with it. This is like totally fine for us.
For the AMD I'm sorry if I ask
Okay.
my question.
Yeah.
How many people? For the AMD Pensando piece, are you using the Pensando PSM to manage the infrastructure?
No,
Or is it going to be, no?
no.
Gonna be-
We basically we're putting our control plane onto the NIC.
Okay, all right.
So this way we don't have to go through like multiple layers of software. And the way we're thinking about data planes is slightly bit different from like how Pensando thinks about or like firewall rules and all that stuff. And we're gonna like run a lot more than just like security rules on it.
Yeah, and maybe you'll get to this, but with these components and all this stuff, I mean, this looks really impressive and looks really interesting, right? To kind of have this kind of full stack running, basically cloud-like network on my on-premises network. Great, right? It's a dream. What does the install process look like? I mean, so like
You download an appliance,
yeah,
you install something with CPU and memory, like a NOC. We require like a couple of Ethernet ports, so you have like you have it hooked up to the fabric, and like you have on the other side you can hook it up to like whatever management network you have. Then you press a button, it boots, and like the entire network comes up. We insert our control plane automatically. We're going to talk about ZTP in a second, but it's like completely automated. The whole thing is designed to be operation for like hands-free operation. So you bring it into the environment, you like set up your rack, you like press the power on, and it just comes up. So this way, when you're deploying things at the edge or at data edge, where you cannot have a dedicated networking person attached to a rack, like this works.
I'm interested to see how.
Yeah. So topology supported for like very simple environments. We do collapse core, which is like 2 top of the rack switches, and you can like throw in a couple of our gateways. We obviously support class, as you would expect, and basically that's like a normal BGP fabric, the RST 7938, and now we'll support small meshes. So if you have like small enough network and you don't want to waste money on spines, we'll just like hook things up in a mesh, and you can hook up like gateways to that and bunch of compute gear. We don't need a separate out-of-band network. We basically manage everything in band. We police and control management and protocols traffic, because like you're now sharing stuff with a tenant network. And we also like do like full-on isolation, not just like from performance perspective, but also from security perspective. Switches, and this is a big deal for us because we have to modify ONI for this. We can boot switches on front-end ports, front-facing ports, or front panel ports. So like you don't have to build a separate management network, and like things will just chain boot. We offer a lot of
Question.
Yeah.
This is Michael Winston from Fiserv. So my question is, you had mentioned early on that this was, I wasn't clear if it was is this a managed service? So do I just say I need N number of compute resources to be able to build VPCs and whatnot inside my data center, and you show up with all of this pre-configured? Or is this pieces, parts, and pick things, and our own engineering teams build, manage, and maintain it?
So you bring your own gear. We let you we provide a software appliance. You create a wiring diagram, and we'll talk about it in a second. And you basically boot it, and then it runs on your resources, and you manage your network, like with our stuff.
Software only, we manage our own stuff.
Yeah.
Okay, that's very helpful.
Right. It's not a managed service, but like this thing can be used to enable others to offer managed services.
Right.
So, for example, if a value-added reseller wants to get into managed services with a network, like our software can be used for that.
Hey, it's
So
Remington. I work for a not-for-profit research hospital. I have two questions if I can fire in. Do you mind going back just one slide? You
Mhm.
mentioned the fully isolated management and control plane traffic. When you say isolated, do you mean like you're logically isolating it on its own virtual network, or are you saying you're dedicating specialized ports,
we
interface?
don't dedicate specialized ports.
Okay.
Obviously, like on the fabric, like where you hook up things to the fabric, yes, but
Yeah, yeah.
within the fabric, no.
Gotcha.
That would be like cost prohibitive.
Yeah.
Like you're burning very expensive ports.
Yeah, I was like, okay.
Like
And then
it's purely logical.
yeah, I gotcha. Okay. And then the second question was, is the software also managing the, like, say, the firmware upgrades for, or software version upgrades for the switching and compute infrastructure, including the DPUs? And if so, when you don't have a separated out-of-band network, do you have some sort of automated rollback function? I recognize I asked like 4 questions in one there, but my brain is sort of chewing through how you're going to be doing maintenance on this infrastructure without out-of-band if you cut your own arrows.
That's
Yep.
awesome question. So first, we don't manage GPUs, but GPUs we do update.
Okay.
Like anything networking,
Right.
we take care of, right? So like our gateways, the switches, we're a lot updates. Updates are rolled out in a very controlled fashion. So you have policies like that take advantage of the built-in redundancy. So like if you're like using multi-homing on the servers, we know that like, hey, update left side first, right side next, and like don't update like this kind of critical regions together. So like all of this stuff is coming. When you completely screw up and you have to do rescue, we have number of steps that you can use to recover. So the most extreme one, when like things like completely foobar, you can have a USB rescue. So you go to the switch, stick the USB stick, and it basically cleanses the box, resets everything. So like this is when things are host. For things that are like rebootable, we can deal with it. So does it answer your question?
Yes, it does.
Yeah.
Everywhere where we apply the configuration managed like switch, for example, we have a kind of different rollback strategies. So if it will see that the applied configuration is wrong in some way, it will roll back to previous known configuration that was tested and it's saved locally. So even if our control plane is completely down for some reason, all the network will keep working. And if you reboot switches, if there are some problems, they will be able to roll back on their own without the even control plane.
Yeah. So like we have like strict separation between like our control plane and the data plane. So like if our control plane croaks, nothing happens. You just like can't configure anything. So
yeah, the control plane is to change configuration, but to keep current configuration running, it's not required.
Yeah. So we'll support. So currently we support IPv4. We're working on supporting IPv6. Like our early customers, all IPv4, as you would expect. For multi-homing, MLAG and ASI, depending on like what the platforms support. Either like there are a lot of SONiC platforms that don't do ASI. Some of them don't support MLAG, in which case like we recommend if you want to have dual homing, just like do it at layer 3. So you need to run a little bit of routing at the Linux host or whatever OS you're using. Back to the network infrastructure services, we provide built-in DHCP service. So like if you want to boot compute or whatever appliances that are attached to the network, you can rely on the DHCP. We provide IPAM that kind of fits into our VPC and tenancy model. DNS is coming. NTP works. So we have the ZTP service we're already kind of touched upon. And where we're heading, we basically want to provide all of the infrastructure required for booting compute. So you have a clean environment, you bring this up, like you put in your images, and then you can like basically bootstrap your entire environment and image the servers. And last but not least, for like purely operational things, like we want to provide IPMI and console gateway. So you can use us as a management network for the compute side of things.
Remington, I have another question, if I may. Do you have the ability to, I see you have built-in pass-through service on NTP, which I'm presuming means you could get NTP sourced from somewhere else if you wanted, which obviously you're going to have to get it from somewhere to start, so tracking all that. But do you have the same ability, or will you plan to offer the same ability around IPAM or DNS or DHCP-related
absolutely.
services?
Yeah, every service we provide is completely opt-in.
I gotcha.
You can like hook up, we have a special construct for hooking up those things.
Sure, okay.
Yeah. So like obviously with like DHCP, we do the DHCP relay.
And kick you out.
Yeah.
Gotcha.
So basically
Cool.
like send it somewhere where your stuff is. And you can still isolate your like kind of shared infrastructure in a clever way.
Michael, again, one of the other questions I had and wasn't clear to me, is there a separate software-based controller that runs the overlay that's used for automation, for creating and instantiating the infrastructure?
Yeah.
Or is this write Ansible playbooks and calls, APIs, things like that?
No, that's so our control plane is based on Kubernetes. We do have master nodes running on the controller nodes. So basically, you need to have something with CPU and memory. Yeah, I already mentioned when we were talking about hardware. But like, it doesn't have to have like a supercomputer to run on. Like it can run on like pretty Spartan compute.
I guess that brings me back to the concern that was expressed earlier about no out-of-band management, having the controller connected to the same infrastructure, bit controlling without an out-of-band connection, but maybe we can address that later.
So we don't require management network. If you want to have management network and like for your management tools, you feel free. Like you can even like use Hedgehog to run it for you. It can be like kind of medley recursive, but it's possible. Like we don't stop you from having a management network. We just like provide you stuff so you don't have to. Which is a big deal when you deploy things at the data edge, where like you're trying to cost optimize and you don't want to build just another set of things. And also like everything consumes power. So the less stuff you have, the better off you are.
On the network at Orly, network infrastructure services, besides NTP, is there PTP support? Are you doing the architecture for PTP for?
So we are going to once we have platforms that support that.
Right.
Like we're kind of like confined by what Broadcom
Right, that's
provides.
more of my question.
Yeah. So like you can't really do it 100% of software. Like you need to have support in the switches. ZTP. So we do. So basically, we bring up the network automatically. There is a wiring diagram where you show what the network needs to look like what things attached to it. And then for each of the switches that we support, like there is a piece of metadata that normalizes the switch, so like we can work with it. So like all of the port nomenclature, so like everything looks the same. Because if you look at like normal Sonic switch, like from model to model, like the ports are named and numbered differently. Like you create a breakout port and just like you use like pretty bizarre numbers. So we have like a very nicely abstracted way of dealing with this. We do chain booting. So like first node boots from the control, like the node that's attached to the controller boots first, then you boot the rest of the network through the nodes that are already up. Down the road, we're going to provide caching at the switch level, so you can boot from your neighbor. And in the process of booting, the wiring diagram or bits and pieces of it get distributed to the switches, and they know what to do. They know exactly who they are. They know who they need to be connected to. So like everything is like continuously validated. So you don't end up like in a non-deterministic state.
So when you have listed on the fly wire validation, which side are you validating? Are you validating the topology that you built was correct, or that how it's configured is?
So because we're configuring, we are making sure that it's wired correctly.
Okay.
So if we expect like
the presumption is someone wired it correctly, and you're just validating.
And then we're not going to bring it up if like it's wired wrong.
Okay.
Just like.
How do you notify back for telling them that it's wired?
There is you can look at the state.
Standard display says please go switch these two.
Yeah.
all interaction with our product is through the API for both configuring the fabric and configuring like switches and VPCs. It's all API. But when you push some changes in the like to the wiring diagram, for example, you will get the status of these objects that will say that if what was applied, and if not, what was the error, what are the recommended changes.
Yeah, so it's like pretty easy. Like you can go through CLI or you can go through API, and whatever. Like it will probably show up. It will also show up like in like Prometheus and whatever other tools you hook up your network to. So this is switch profiles. So provides metadata for specific switch models. So like anything that is like platform specific is abstracted there. So like how you deal with port numbers, port names, how you deal with like capacities and capabilities. So we don't have to hard code the models in our code. The wiring diagram basically contains like what you would expect. It's like base switch configuration, links in the fabric. So like we have this object in our model called connection. So it's like how switches in the fabric connect together and like how they form the fabric, and then how the servers connect to the fabric. So we always know the impact, like when you're like twiddling a port, you need to know like which servers you're affecting. It's sort of basic. And a lot of people like know this at planning stage. So we might just as well like take advantage of that. And then there is a configuration for how we deal with the external world. We have a special set of external objects, basically how you deal with stuff that connects you to other networks and to the internet. At some point, gateway will be the thing that connects to the internet. Yeah.
Jeremy Schulman. So what I see on the screen here is what appears to be like YAML files.
Yes.
Yeah. So then the end user, in this case for your customer, was a DevOps engineer, very familiar with setting up YAML files. Or are these provided by you guys in the form of like a template where they can just fill in some of the blanks? Like, what's the friction between, you said I download the software onto this box, but now I have to, do this kind of configuring. What does that process look like for your user?
So a lot of people are already familiar with the concepts. Like,
Yeah.
Obviously, like not the wiring diagram, but like especially VPCs. So like our assumption is that a lot of people already have runbooks for that, and like they have like scripts that can deal with this because like we already run something in the cloud. We'll provide templates. Like we'll at some point we'll also do like the Terraform things and Pulumi support. But it like is actually pretty simple.
Yeah, but they have to write these themselves, or do you give them samples?
Oh, we have samples.
Yeah.
Yeah, we have samples for everything. We have a couple of different like topologies that kind of we think that users will be starting with, and mainly you will change the ports, like how like which specific ports are used, like for example on the switches, and you can use these example files at the base.
Has any of your customers ever asked for like a GUI that would allow them to draw something and then it would produce those files so they didn't have to artisanally handcraft YAML files?
Yes. Yeah. It's coming later.
Yeah.
Like we're gonna have what we called Fabric Designer, and it's gonna run in the cloud. So you'll be able to like specify, like connect things visually, and then like it will spit out purpose-built appliance for you. So like with all the security keys bolted in. So what you download, you don't have to configure.
Good.
Right. So we are thinking very hard about like how to consumerize this even further, and make it like super easy to use. Okay. Now, Sergey.
That's a demo part. Okay, well, I guess we'll start with a bit of a like overview of the topology of the environment that we're using for demo. We have a couple of edge core switches, Dell and Supermicro. Mike was talking about the chain boot. So in this case, we have the control node connected only to the two leafs, leaf 1 and leaf 3. And we require at least one connection, like 2 and more, just for reliability. So the leafs that are directly connected to the control node will be provisioned directly from control node, and then the spines will be provisioned from them, and the rest of the fabric, the other leafs, will get provisioned from the spines. That's how the chain boot works. And in the demo, we'll look at the server 1 and server 4, which are connected to different switches. And server 1 is actually multi-homed to the leaf 1, leaf 2. So it will give us basically the like look and feel of traffic going through the spines between them. Okay, so so you can see here I'll run it one more time. We have a CLI that is just a plugin for the kubectl. As our API is basically extension of a Kubernetes API. So any Kubernetes tools could be used with our API as well. And we provide some additional like CLI tools to make it easier. In that case, it's we'll show a lot of like inspect objects CLI. Like in that case, it's inspect fabric, which gives the overall like sound mile view on the control nodes and the switches. In that case, it shows like that everything is in ready state and when the configuration was applied. And there are other things that we can use, which is like inspection of a switch, which will give the actual state of what's configured on a switch, which ports are in use, what are the counters on the ports, and things like that. So Mike was talking about the connection object, and that is just basically every port usage is a connection object. And you can see here, for example, the server one have its connection that is going to like 2 switches, and as we looking at one of the switches, we know that like one of the ports is like have type MCLAG and have this connection configured on it, and we know like what transceiver is used there, the admin and operational state, the state of a transceiver, speed configured on it, and things like that, and like then we have the snapshot of the counters, which is continuously updated and available through the API. On the other hand, we're pushing it to like Prometheus or like Mimir compatible APIs from all of the switches.
I have a question.
Yep.
I'm sorry to pull you out of this part of it. I feel a little lost. Might be me. It's my first NFT. Who is this for? Is this a management platform for when people building AI clusters? Is this for people managing non-AI clusters to give them a cloud-like experience on-prem? I'm trying to get my head around the value prop, the use case, who's using this for what?
So this is a platform for anybody who grew up in the cloud.
Anybody who what?
Anybody who grew up in the cloud.
Grew up in the cloud.
Yeah. So, and it allows them to basically build things on-prem and get the network out of the way. So we do some special things for AI, which we'll discuss in the end of the presentation. The focus of our appraisal was like to show the cloud UX, but it's basically for people who want to build private environment and have a reasonable abstraction. So like people who grew up in the cloud, which is like majority of people now.
So to put meat on grew up in the cloud to build a private cloud, this is your management solution to build your own private cloud.
Yeah.
All right. Got it.
For the network.
Okay.
Yeah.
Thank you.
But when you say people who grew up in the cloud, you're saying, well, they're familiar with Kubernetes. They're familiar with using YAML-based infrastructure as code techniques. These are all the core concepts.
Exactly.
So some people who may not be familiar with those things, this might look a little foreign to them, I think.
And a good example of a person who would like use this is my older kid. So he's working for an AI company. So like they got some GPUs and they're running stuff on-prem, and like he was on the hook to like hook at a lab, and he's like, "Dad, this is like your stuff. Like, why is it so hard?" And like this kind of stuff will like make it super easy.
Can I use this if I'm not running an AI cluster?
Absolutely.
Okay.
Like you can use it for like anything. For AI, like you can use like what we're demonstrating is for the front end networks, which is basically like how the applications like talking to each other and how they're talking to the outside, how you tether them to the public cloud. But like it's applicable to anything.
Okay.
Obviously, for a startup like ours, majority of customers actively building out infrastructure are kind of like doing AI and like building out like a lot of like AI compute capacity. So we fit very nicely into that.
So on that though, what within networking versus AI networking or networking for AI, what makes Hedgehog? Because I can see that it makes this private cloud management plane kind of easy. What about Hedgehog makes it uniquely suited for AI workloads?
So QoS, the way it's built into our VPC model, we'll talk about this. So you can basically run converged networks or you can run separate backend networks. And the stuff that we're doing, like that's basically roadmap. So we're going to be doing flow scheduling and doing like a lot of stuff in the DPUs to aid with like saturating the fabric nicely, like in a way that's super innovative.
Okay.